So in this video, we want to try to take the information that we've been given and build a bridge with all of the information we're given and that we can imply and infer from, and until we have the measure of the angle that we're after. So we're given two arcs, and we want to rely on the information that we know about inscribed angles and central angles to bridge from one piece to the next, to the next, to the next, until we figure out the solution. So let's look at what we know first. First, we know that the measure of JL, the arc JL, is 50, and that's labeled here, and that's from here to here. Okay, and then it says the measure of the arc HK is 65. That is from here to here, so we can label that as 65 degrees. And then the other thing we see that it's not written here is that we see that the center of the circle is A. Okay, so and then it wants us to solve for the measure of MK. So let's do that in red. The measure of MK will be from here to here. We want to know what this is. All right, well, we see that the measure of the arc JL is intercepted by an inscribed angle. And we're going to look at that angle in green here. From J to L is intercepted by this angle. And this is called an inscribed angle. And it's an inscribed angle because the endpoints, J and L, as well as the vertex, all lie on the circle. And we know the relationship of an inscribed angle and its intercepted arc. The inscribed angle is half of the arc. So if the arc is 50 degrees, then we know the angle is 25. Okay, so there's one relationship. Well, we also see here that this here is 65 degrees, and it's subtended by a central angle, and that is this angle here. And it's a central angle because the vertex is at the center of the circle. And we know that a central angle is equal to its subtended arc. So that means this angle here is 65 degrees. Well, if that angle is 65 degrees, we see that it is vertical angles with the angle across from it. So that means this is also 65, which happens to be a central angle as well to this angle, which means that this arc is also 65 degrees. Okay, well, the other thing that we see here is that we have this angle here. This angle here is an inscribed angle of 40 degrees. The reason that's important is because here is my intercepted arc from here to here. So we know that an inscribed angle is half of the arc. So if 40 is half of the arc, that means that from F to M must be 80 degrees. And now we can get at this piece here from M to K, because we know that if A is the center of the circle, that means that this line here is a diameter. If that line is a diameter, we know from this point to this point is 180 degrees. Therefore, the measure of M to K, which is what we're solving for, should be equal to 180 minus what we already know, minus the 80 degrees and minus the 65 degrees. Well, the 80 and the 65 makes up 145, and we subtract that from 180, we get equal to 35 degrees. Okay, so this piece of information didn't really play a piece in solving for it. We could have done without that, but it is a good reminder of an inscribed angle and its relationship with its subtended arc. But you see how we were able to go from one piece of information, from this piece of information, because we knew that, we knew the central angle. Because we knew the central angle, we knew the vertical angle on the opposite side and its relationship with its subtended arc. And then we were able to use another inscribed angle, and then finally use basic arithmetic to subtract the two arcs that we knew, the 65 and the 80, from the central angle and inscribed angle relationship, from the 180 to find this missing piece right here. And our final answer is the measure of MK is 35.